Given the graph of the function f, use this to sketch the graph of y equal to f of x minus 1 minus 2. There are a few operations being done to the original formula f of x. First, the input x minus 1, and then we will take the result and multiply 2, and then lastly we subtract 2. Now the last number minus 2 is what we call the vertical shift. It moves or it shifts the graph down 2 units. The number -1 inside the parentheses is the horizontal shift. It will move the graph to the right, not to the left, but to the right 1 unit. And the number 2 will double the graph, so this is a vertical stretch. Always perform vertical shift in the last step. To help us sketch the graph of this final function, we're going to make a table. Since there is a horizontal shift in the graph, we're going to try to include numbers that are outside of the original domain. Just for fun, we're going to start with x equals -2 to see what happens. When x equals -2, y is 2 times f of -2 minus 1 is -3 minus 2, and we know that we do not have this information because the original graph f is not defined at x equals -3. Similarly, if we were to plug in -1 into this expression, then -1 minus 1 is -2, and so we can't evaluate this because once again -2 is not in the domain of the original function f. And so we're going to skip a few here. When x equals 1, we plug 1 into this expression. X minus 1 is now 1 minus 1, so it is f of 0. And so yes, we can evaluate f of 0. F of 0 is 0, and so 2 times 0 is 0. 0 minus 2 is -2. And so we have our first point. When x equals 1, y equals -2. That will be on the graph. When x equals 2, we plug 2 into the expression. 2 minus 1 is now 1, and we still write the coefficient 2 in front of f, and we still need to subtract 2. Now f of 1 from the graph, we know that f of 1 is 1, and so this is 2 times f of 1 is 1 minus 2, so 2 minus 2 is 0, and so this point 2 comma 0 will be on the graph. When we plug in 3, 2 times f of 3 minus 1 is 2, and so 2 times f of 2, originally f of 2 is 2, and so this is 2. So when x equals 3, y equals 2. When we plug in 4, 4 minus 1 is 3, and f of 3 is 1, and so we have 0. The new point is now 4 comma 0. Remember that we plug in 4. When we plug in 5, 5 minus 1 is 4, and so 2 times f of 4, originally f of 4 is 1, and so we will still end up with 0. What happened when we plug in x equals 6? 2 times f of 6 minus 1 is 5, and we just simply do not have this information because 5 is not in the domain of the function f originally. The domain of f, the red graph here, is from 0 to 4 only. Alright, now to connect the first 2 points, we're going to use the line. Again, the shape of the graph should be maintained proportionally. And then the last 2 points, we draw a horizontal line. Now for the middle part, we're going to draw a rounded graph. And so this is the graph of the transformation y equals 2 f of x minus 1 minus 2. Alternatively, we can follow the order of operation to do the transformation. And so first, we will shift the graph to the right 1 unit. And then we would scale it or stress it by a factor of 2. And then the last step, we would shift it down 1 unit to get the original graph. And so if we were to do this step by step, then first we would have to move this graph to the right 1 unit. And so we just simply copy the same graph, but we're going to move it to the right and move it to the right, and then the semicircle to the right. The next step, we're going to stress this graph vertically by a factor of 2. And so for the given x coordinate, we're going to double the y coordinates. So when x equals 1, y equals 0, then we double y equals to 0. 2 times 0 is still 0. When x equals 2, y is 1 now. So when we double it, we get 2. And when x equals 2, y is 2 now. So we double it, we get 4. And then double it. And then when we double 1, we get 1. And so this is the graph after the second step, right? And then lastly, we would shift this graph down 2 units. And so we're going to take whichever the graph that we end up with in the last step, which is the green graph, and we move it down 2 units. And so when x equals 1, we'd move it down 2 units. When x equals 2, y equals 2, bring it down 2 units. When x equals 3, y equals 4, we bring it down 2 units, and then down 2 units, 2 units. And so we, again, just simply copy the graph, but this time bring it down 2 units. And so this is the graph of y equals 2 f of x minus 1 minus 2, which is the same as the graph that we obtained earlier when we made a table.